Okay, hi everybody. Let's get going with this. As already said, I'm Konstantin. I guess you all don't have internet, otherwise that Twitter handle is important because I'm not going to take questions during the talk. I'm not going to take questions after the talk. If you have anything about the talk, please bitch on Twitter, or it's also acceptable if you just cry a little. I'm fine with that. I'm from Berlin, where it's snowing right now and cold and everything, so I'm really happy about being here. As Josh already said, just like him, I work at Travis CI. I maintain Sinatra and work on projects like Rackup and Rubinius. And to do a little more advertising, together with Alan Harris, I wrote a book where there's this discount code. You can get 50% off the ebook, 40% off the print, which makes the ebook $650 US, which is like a pot of beer here.
Even less.
Even less, yeah. And one other thing, before you get really comfortable, is real-time Rails and Ruby is actually in the other room. Seriously, you will learn nothing useful in here. So if you came to this conference to learn something, then now is the time to leave this room. Okay, no one left. You have been warned. This talk has 99 slides, but a meme ain't one of them. Prepare for the strangest code slides you might have ever seen. In the beginning, Mats gave us Ruby. This is Mats giving us Ruby. That down there says Yukihiro Matsumoto. Maybe. I copied it off his Facebook page. Backwards, okay. If you don't know Ruby that well, here are a few links you can check out to learn more about Ruby. One of the things I'm going to talk about is obfuscation. Basically, the theme of this talk is how to do fun things to your code. And when it comes to obfuscation, there is a quote that I like to recite now and then. Until programmers stop acting like obfuscation is morally hazardous, they are not artists, just kids who don't want their food to touch. And that quote is by Y. Okay, let's get started with fun Ruby code. So I said you're not allowed to ask questions, but I'm allowed to ask questions. So first question, who knows what this evaluates to? Scream at me, come on, come on. WTF? No. It actually evaluates to false. Because this is actually in 1.9, question mark, exclamation mark is a string, the string exclamation mark, and in 1.8 it's an integer. So since we established that this is false, what is this? This? No, this evaluates to, there's a ternary operator in here. You don't need spaces. So on 1.9 or 2.0, which is coming out in 3 days, it evaluates to colon. Obviously. Okay, something easier, because so far you've not been really great at this, I have to say. Something easier. What does this evaluate to? Correct, cafe. If you look at this here is an array and pack is your best friend ever. If you write code, pack. If you change those to not do integer to character conversion, it's .16. That part in there is actually 2s. So it's the same as sending 2s16 to that integer, which is the same as writing that as hexadecimal number. So that's just wanted to find a useful, simple example for a pack. Another thing that's really good besides pack are here docs. Here docs are one of the best features in Ruby. Okay, guys. What happens if I run this code? It's correct. Name error, undefined method or variable foo. Because this part is a string. This is the marker for here doc starts here, and the delimiter for ending the here doc is 4 spaces. And then you have 4 spaces down here. Now that we have some tools, one really good thing, if you want to have fun with your code, is the art of distraction. Just write code that looks like it does something different. For instance, if you run the following code, what will be printed out on the screen actually? Come on, anybody, any takers? Don't be afraid. I won't make fun of you if you say something wrong. Maybe a little, but no one? No. This actually just, how did that happen? Correct. It just prints, how did that happen? Nothing else. And that's because if you reformat that code, it actually looks like this. There's a block up here that never gets evaluated because between does not use a block, but also it does not complain when you hand it one. And since 1 is not between 2 and 3, you end up down there. If you look at stuff like obfuscation or quines or other things in Ruby, there's one guy you will come across, Yusuke Endo. You probably have seen code from him. His most famous code is this. You don't really see there's Ruby code all over the place here. But this is a valid Ruby program. It's not a real quine. A quine is a program that outputs itself if you run it. Instead, this program, if you run it, it's valid Ruby code. It outputs a different program that looks like this. If you run that, you end up with this. If you run that, you end up with that, and so on, until you're back with that. We get into a second. In a second, I will get to why I showed you that. He has a ton more. Just check him out on GitHub and his blog, which has not been updated in 3 years. But let's first look at one more really useful feature we have in Ruby. It's called flip-flops. And I'm not talking about these flip-flops. I mean, you would probably not confuse it because they're called thongs here. I'm actually talking about something inspired by these flip-flops. Flip-flops are basically the basic implementation of memory. They store 1 bit and you can flip them over. A flip-flop in Ruby looks like that. Any takers to what will be printed out on the screen if I run this? Come on, scream at me. I see some nodding there.
Yeah, it prints out 3, 4, and 5.
Correct. Because it starts evaluating. First time it runs, I is 1, and 1 is unequal 3, so it evaluates to false. So on until it reaches 3, then this is true. And the next time it evaluates with 4, this is false and that is false. But the last time it visited that if clause, this was actually true, so it just remains at true. It's obvious how such features are really useful when you write code. I highly encourage you to use this. So just to check if you understood it, what does this evaluate to? What does that print? It just prints 3. Maybe this is not what you want. Maybe. because maybe you want the second clause to be ignored if the first clause is true. Since that is also a really, really common use case, you can just use 3 dots instead, and then the value of the second clause will be ignored if the first one is true, and it will print out all numbers starting from 3. Perfect. I mean, when I see that, I just actually want to stop giving my talk and start coding with flip-flops right now, to be honest. Unfortunately, not everyone thinks they are a good idea. So there has been an issue opened, which has not yet been closed, which might lead to flip-flops being removed in Ruby 3. It was opened by Magnus Holm, who said, can we please get rid of flip-flops? But then, our good friend, Yusuke-san, I'm not sure if I don't really know anything about Japanese, sorry, came along and said, hello, I'm one of the few users of flip-flop. And he pasted some production code. It looks like this. If we check out what this actually, does, am I still on? Okay. I have it here, you see, in the file ffrb, and just let's see what happens. Let's see what happens if I execute this. Perfect. Okay. So, given that, I think we should really keep flip-flops around. Unfortunately, he himself does not necessarily think so. But anyways, so this was a real-world use case for flip-flops. And Evan Phoenix from Rubinius always said, I won't implement flip-flops for Rubinius until someone actually has some real-world code. So when I saw that code, I was like, yes, I'm going to implement flip-flops for Rubinius. Which I did. It's in. Interestingly, I was able to implement it in pure Ruby. And it's the most stable feature of Rubinius ever, because we had never had a bug report on this feature. Just to give you an impression, the main part of the implementation is this bytecode generator thing, just to show off a little Rubinius. It's actually implementing a crazy feature like that takes this amount of code approximately, all just Ruby. And the tests were already there because of RubySpec, which was also amazing. But I'm not actually here to show off Rubinius. I'm here to talk about way more real-world use cases, because any one of you running Rubinius in production, right? So let's talk about Almost Sinatra. It's a project I started over a weekend just to see how I can squeeze something that seems to be Sinatra into as little code as possible. And I ended up with something that's just 6 lines long. What's important here is that obfuscation was never the goal. The only goal was to use as little code, as few bytes as possible. And obfuscation was just a byproduct of that. The coding guidelines were, in the beginning I said like below 10 lines, ended up with 6, and it couldn't be wider than my editor, so a line could at tops be 120 lines, 120 characters. And this is the code. This is a Sinatra implementation, way shorter than the official one. So what can this implementation do? It has configure blocks, it supports sessions, you can store stuff in sessions, you have helper functions, you have before filters, you can obviously use routes, you can set instance variables that will be passed on to your views, you have params, like if you pass a name as a query param, you can access it, you can hand it as locals to the views, just like you can, like basically everything Sinatra can do. It supports inline templates. I'm not sure if you used it with Sinatra, with this, where you can just say end at the end of your Sinatra file, and then you can have all your templates in that one file. which is also really useful. And the fun thing was, there was for me just like a fun project I did on the weekend. A few days later I tweeted about it and put it on RubyFlow, and people got really interested. There were at least 4 different blog posts trying to analyze that code. None of that for me, obviously. Like, I've not written about how this thing works. And actually they were quite useful, because I did that nearly 2 years ago. And some of these were quite useful when I tried understanding what I actually did there. One of the main approaches I use is simplify and compress to squeeze out code. Because if you look at what's actually needed, so it needs a few dependencies, it needs signal handling because you want to send Control-C and stuff. And if you just look at that, how you would write that in normal code, that would already be 6 lines. If you remove that empty one, it would be 5, so you would have 1 line for the rest of the functionality. So let's simplify this. Obviously, it's way simpler to use arrays here and loop over them. Now I can see, like, okay, for dependencies that, and that for signals. And now we can compress it. And by compress, I mean take 2 things that do different stuff and just smush them together. Which ends up with this. And there's a lot of boilerplate in here that we can get rid of. First off, all those quotation marks and stuff, just be done with it. And there's another neat thing. So as you can see, like, this would throw a load error for trap, for term, and then trap would run. But so if something ends with a curly bracket, then you don't need a space after it. So if we flip the 2 around, we can save a space here. And also, really, really important, I discourage everyone from using each, because map is 1 character shorter. Then it's just removing spaces, and obviously there is some, this can be removed too, but then it wouldn't fit on the slide. And yes, and then something cosmetic, which actually doesn't save a byte, but makes it look smaller. You can use any character instead of the square brackets. So one character that's nice to use here is actually a dot. And if you look at the code, this is actually the first line of the 6 lines. This is still the 8-line version, I'm sorry. And yeah, this is one of the 2 main techniques. The other one is fake it till you make it, or just fake it. And if you look at the code, then a lot of the methods that I showed you, where you can say get that, post that, etc., they don't really work properly, but for any simple enough Sinatra app, you will not notice. For instance, if you say it does not matter if you use get or post or put or delete, it actually just uses the rec map method that you have in Rackup files. It also means that when you say /foo, you could, that route actually also matches /foo /something. But whenever you just try out almost Sinatra, you will not notice. Yes. And it just does other stuff like pull in stuff from rec. Basically anything rec gives us is for free because it does not really cost us that many characters. And so the thing is, you see that I'm looping through the methods, but metaprogramming, like I could either do an eval there with def, that string, or I could do a define method, etc., but that actually costs a lot of bytes. Like define method is what, I don't know, more than 10 characters long. I'm not going to count now, I'm lazy. So what you can do is just grab that define method object and store that for later. Because then it actually just boils down to calling that method object. This is a nice syntax for doing that. You could use, so call has a lot of aliases. You could use square brackets, but if you use square brackets for call, then you cannot hand on a block. If you use this syntax, you can hand on a block, so that's one character more than square brackets, unfortunately, but it works. So that's basically what I do all over the place. What you also see is that all the methods are just defined on object, and that also means that you don't really have to care if something is called on request.params or whatever, because every object in the world will just respond to that method. It also loops through all the templates that are known to Tilt, which is the rendering engine from Sinatra and Sprockets, and just take the file extensions that are known and define those as methods. Which also means that you don't just have a markdown method, you also have an MD method and a TT for textile, which Sinatra does not have. And yeah, and the whole set enable, disable, configure, help us use, register is all more or less fake. It just tries to send that to the rec builder object, or no, actually it's all fake, but that doesn't matter because usually you don't notice that. And yeah, and that's one of the principles. And yeah, the last thing that's really cool in there, or that's actually a real implementation, is just parsing out the templates. It just uses a regular expression for finding templates, which has the cool feature of you actually being able to define inline templates before the end, because the end is just ignored. Which also means that you should be careful if you use class instance variables. Because they also start with @@. Yeah, and then all you need is just run the server. Port is of course hard-coded. Everything else is of course also hard-coded with sane defaults. Since it's just almost Sinatra, it does not actually support environments, but yeah. And end is a really, really cool feature in Ruby. Actually, Sinatra itself uses it too, except it uses @exit. It basically says whenever you're done with running your code, please do whatever is in that block. So it starts a server. The main difference why Almost Sinatra is using end, which has two really cool features. First feature, it's syntax instead of a method. It's always better to go with syntax instead of methods. And the other feature is that end is simply shorter than @exit, right? I could have had that actually just in the. So why this has to be an end is so that your code can be run before you start the server, because otherwise it would never load the routes and just start the server. And the cool thing about such syntax is also that you can basically just place it anywhere in the code. And yeah, you also see that the request, since we don't have an application instance or anything which you would have in normal Sinatra, but that would just be craft, the request object that Rack gives us, is just stored in a global, which makes it, this makes it really, really easy to access it. We are using a global variable here instead of a constant. So if you would use a constant, we did in other parts. I did that in other parts. It's small now. But if I would have used here a constant here, then you would have gotten warnings on every request that the constant is being redefined, and we don't really want warnings. Do we? So that's also why we have to use rack-lock, which means if you want to scale almost Sinatra, you need to do it the same way you scale every other Ruby application by not using threads, but instead use hundreds of processes. It's really battle-proven. But I mean, it's hard-coded to the webbrick handler, and why webbrick actually supports threads, the webbrick rack handler does not support threads. So, yeah. As you might have noticed, it's all about the fun. And I wrote extensive coding guidelines, and I'll just hammer you with quotes from myself from now on. If your app does not run with almost Sinatra, please open a Sinatra issue. Versions are to software what Subversion is to Git. So the suggestion is that you just copy that code and paste it onto the top of your file. Also saves you a require, and then just put the code below it. One other guideline is don't include tests. Tests just bloat the code base. Just commit. The users will complain if you break anything. Did I mention Rocket Travis CI? Anyhow. Apparently, this code is really, really stable. I don't think I had anyone coming up with really serious bugs. So apparently, all the users are really happy with it. I can only recommend you going for almost Sinatra in production. I mean, it's so little code. You can do a code review in, what else? I played with other stuff too, getting it to be really small. It never got as popular as Almost Sinatra. I think Almost Sinatra probably was the most successful project I've ever been working on. So Almost Sinatra actually has one really downside. Rack is a huge dependency. Like all that logic in Rack. So I wrote Almost Rack. To prove that Rack is actually simpler than Sinatra. It has some slightly different rules. For instance, all the lines must be the same length because it looks nice. And it has to be it has to be no more than 120 characters per line. Which in this case, so it's the same rule as with Almost Sinatra, but in this case I actually had a different idea behind that. The idea was that I can fit it into a tweet and also add a hashtag. And it works just like you would expect. If you take this Rackup file, it has a middleware that's in there that's also this time really called, not like with the use method from Almost Sinatra where it's just ignored. You pass in the normal rack application, response to call, gives you status code, headers, and the body object. And this is the code. 3 lines, all the same length, and you can't really read it, but this is not important. Also put it really large on here, and you don't really see that either. But anyway, so it's hard-coded to open on localhost 9292, like Rackup does. So this is a file called almost Rackup. It's executable. You see that by the shebang line, and you can just run that, and we'll load your config RU. And nice things that it does is in HTTP you have that message. For instance, status code 200 is OK. And status code 44 is file not found, etc., etc. This is just hard-coded to OK. It also gives you statistics about how long the request processing actually took, just like you normally have in the logs, except benchmarking this will actually be a lot of code, a lot of craft that we don't want to have in there. So it just totally makes that up and uses random divided by 321. Makes it seem really fast too. Like, whoa. Because random will give you something between 0 and 1. And yeah. Also, one real downside is, if you use almost rec, is the response body cannot be anything that replies to each. It has to be an array of strings, and to be exact, it has to be an array of one single string. That's just a minor downside in my opinion, really. And so you see how we're eliminating the stack. Now you can run almost Sinatra with almost rec to slim down your things, but there's one thing that's really missing if you use that. That is like, you have stable code, really small code, fast code. But what if you get an evil mass assignment hacker or someone attacking your almost Sinatra application? I have one project that you would use with the normal Sinatra. Actually, Sinatra uses that automatically, which is rec protection that defends you against attacks. But rec protection, again, would be such a bloated code base. So I did almost rec protection, which protects you against opportunistic attacks. Goes really well with almost Sinatra, almost rec, or Ruby on Rails. Here is a few of the attacks. There are more attacks out there it's protecting against. But those are the main attacks that I was looking at when implementing almost rec protection. It protects you against attacks that Rails can do nothing against. Like, no longer do you have to fear for the year 2K bug. Sleep really, really well. And crime. Have you heard about crime? I don't mean crime out on the street. Well, it will protect you against cybercrime, but crime is also the attack against SSL, where you can figure out the session cookie even though it's SSL encrypted, and almost rec protection will totally eliminate that option. There are a few things. Like, usually it protects you against race conditions in your code, which is really handy. I mean, not with almost Sinatra, as you can't use threats, but otherwise, because almost rec does not care about threats, so you could use threats in there, whatever, knock yourself out. The only exception is if you use it with proper rec, and your rec handler has race conditions, then will not protect against these. Because basically it just protects against any issues that are in code that's after the middleware. Because almost rec protection is just the middleware you include. And so we all had a good laugh so far. But I have to tell you, security is not a joke. So one really important, which was really important for me, is I do not set a line limit. I do not squeeze anything together as close as possible. I want this code, you go in, do a proper security audit of the code and understand what's going on. And so it's a bit longer. It would actually still be the largest project in your stack if you use that stack I'm recommending to you. And so I had to do a few arrangements to fit all the code onto one slide, actually. This is the almost rec protection code. Let's look at this. It has two public methods, or well, one really important public method. Call the normal rec method, and you can configure it. You can say if it defends you against an attack, you can tell it which status code to use. It defaults to 4.3. You can tell it the message to display, which defaults to attack prevented. You can set the content type, text. So whenever a request comes in, it checks if there is an attack prevention reply for this attack. Because like, if it's an attack, then there is a prevention for that. And otherwise, it just hands it on to the application that it's protecting. So how does it figure out if it needs to prevent an attack? The logic is ingenious. If the request is an HTTP request, prevent the attack. If it's an HTTPS request, prevent the attack. And if it's the coffee brewing extension, prevent the brewing attack by pretending to be a teapot. And of course, as you can see, one array, one string in there, totally compatible with almost rec. Also has fancy logging options. If you want to have fancy logging, you just override standard error. Done. So if you have it in front of your mental image, it simply rejects every request. No more fear for, like, this even protects against unknown attacks in the future. It's perfect. It also has other advantages. It makes scaling your app way easier. You can just turn off your database. Cool. I heard from people using it in production, telling me how amazing it is, protecting against approximately 9,000 requests in an hour. Like, imagine all those attacks. The people didn't even know they have been under attack that much. Yes, so, conclusion. Seriously? Thanks.